Okay, we got streaming. And get rid of this. And then go back to the project that I was working on the other day, which is Canvas 1. Hmm? Oh, right. Okay. I saw the logo because I forgot that that was what we were working on, was trying to make it rotate. Okay. So the rotation is actually based on the heading. So in terms of heading, we talked about this already, but I'll just talk about it again. This way, on the right hand side, is 0 degree, and it goes counterclockwise, and 360 degree is one turn. Okay, one revolution. Okay, so we also talked a little bit about the timer. Um, let's see, the mic, not my mic, but this mic for amplification. The pickup is not that good. I think it has a very narrow pickup pattern. So when I turn my head like this, it doesn't pick up my voice as much anymore. But according to my own recorder, OBS, I can turn my head like this or be directly on top of it, and there's very little change in terms of the amplitude. So that means the school is using a mic that has a pattern that is not really suitable for people who like to turn their head. I can put on that Batman costume. Remember the old Batman costume, where it's really stiff, everywhere from the shoulder and up. So whenever he turns, he doesn't turn his head; he has to turn his whole body, like, "Arr, Joker, I'm gonna get you." I can only do it for like 2 seconds. Okay, so anyway, we were trying to make this logo rotate. Okay, so that's what we were working on, and we got some of the blocks or most of the blocks done already, except at the very last minute, I was using the wrong thing. In terms of, instead of heading, I was using rotation, which is a yes no. Can it rotate? Okay. So we now have to go back here and then do the math. So modulo is basically the remainder of a division. So because we want to make sure that this number stays within 360, so we want to make sure that it is modded with 360. So now here, we just need an addition. So we're basically just saying, okay, take the current heading and add an offset to it. So the offset can be something, let's say 10 degrees. Now let's make it less. Let's say 5 degrees. So now we have the sum specified here, and then we have to specify that we want to mod or modulus with 360. So this way it goes through one full rotation, and then the next rotation starts at 0 again. Okay. All right. So I think this is basically all we need, and my phone is up, so we can now go ahead and build the app like that. All right, we'll save the app as canvas1.apk just like last time, and we'll just replace the current one, go back to my command prompt, and this is from my other class, so I'm going to have to close that first. And we can now go back to, the folder is already here. So with this one, I can just run screen copy so that we can see the screen of the mobile device. And then the other one can run the upload. So I can just run the same upload. Nope, I don't have that anymore. So adb install -r, and then the file name canvas1.apk. Okay, it's all installed. Let's go to the app here. Okay. All right, so go to apps, and the program is Canvas 1. There we go. So we can see the logo, actually just rotating, which is kind of cool. And the other part should still be working, so I can pick up the dot and move the dot around. Whee! And move it around this circle until we all feel dizzy. So this makes an interesting splash screen, I think, especially if you design your logo to be circular, so it can just kind of rotate. This one, actually, if you look very carefully, it's not entirely circular, okay? It's actually slightly elliptical, but it's not that elliptical to the point where, it's easy to tell that it's not circular. So, yeah.
Where it flashes on and off?
Absolutely. If you want to... yeah, absolutely. So how do you want it to go to flash on and off? Like blink on, blink off, blink on, blink off?
That's exactly it, yes.
Okay, and what do you want the timing? Because right now is each step of a rotation is I think is 100 milliseconds, so it will do it 10 times per second. So how often do you want it to blink on and blink off? Every second? Every 3 seconds. That's a long time.
Okay, make it 2 seconds.
Every 2 seconds, so every 2 seconds on and then every 2 seconds off. So, okay, sure, yeah.
Like a flash.
Okay, so let's think about how to do that. Okay, so the mechanism of doing that, it will still be based. Oops, okay, wrong window here. Let me go back to the browser. Oh, it's already on the browser here. All right, so we can use another timer, but we can also use exactly the same timer. So the way we do this is, there are several ways to do it. We got the timer running at 100 milliseconds already. So what you can do is you can have a counter, okay? You just go like, for every 20 times that the timer goes off, which is basically approximately 2 seconds, you alter or you toggle the state of whether this sprite is visible or not, enabled or not, okay? So that's one way to do it. Well, let's do it that way, and then we'll see the effect first, okay? So this means, we'll need a global counter, something to help me count. The other way to do this is to use the heading, because the heading is already a number that is always between 0 and 355, actually, because we keep incrementing only by 5 each time. So if we take that number and we say, well, since we're incrementing this by 5 every single time, if we just mod the heading by, let's see, 5 times 20 is 100, okay? Well, that doesn't work out very well, but it will still work. It's just not very well. We could use a counter, okay? So we'll go ahead and use a separate counter. We actually do not need a separate counter, but it's okay to do it that way. So now we have a global variable. Go to variables and initialize a global variable, and we'll just call this blink counter, and we'll initialize it to 0 as a number. And then inside the timer thing, we'll have another block of code to deal with the blinking of the circular thing that's running, okay? So we'll go ahead and, let me see. Okay, I got it. So you go to logic, because it's going to be a conditional statement to decide whether it's, we should have it on or off, okay? So we'll just have the blink counter to increment at the end of the entire thing. So now we go to, oops, not logic, is control. So we have a control block here. That's it states one of two things. Well, just one thing is fine. So we want to make sure that the blink counter is a multiple of 20. Then we do something, because you said every 2 seconds, right? Okay. So the way we do this is we go to math again. We look for equality this time. And on this side, we are looking for blink counter being, I can check for 0, I can check for 20. So either one would work. Or I can mod it. There are many ways to to do this. So the difficulty is choosing which one I want to use. We'll do it with 20. Okay. So we're going to look at the blink counter. If it does equal to 20, then we'll do something. So what we're going to do is just toggle the state of the sprite. So we go to image sprite and we look up its properties, and enabled is right here. So we'll go ahead and pull this block into here. And then the way we do this is interesting, well, somewhat interesting. We just say that it is the negation of what it used to be. In other words, when it was, if it was on, then it's now off. If it was off, then it's now on. So we are basically just inverting or logically negating the state of the image sprite. Come on, let me move this. There we go. Okay. And then the next thing we need to do is to 0 the counter. So we go back to variables, or we can just pull the set block from here and set it back to 0. So once it counts up to 20, we'll reset it to 0. And then after this block here, then we'll go ahead and increment it. Unfortunately, in App Inventor, there's no quick and easy way to increment a counter, so you have to basically just do it using the math blocks. It's not a big deal. It's just that because incrementing is a very common thing that we want to do with a counter. So in many programming languages, they have shortcuts to do this. But without a shortcut, it's not too bad of a deal. Okay, we can still do it. We can just say that whatever it was, just add 1 to it. No, that's not what I want. Okay, do it one more time. Space and then a 1. Nope. It keeps doing that. I chose the wrong one. Space 1, and it's the last one. There we go. Okay. So now when we look at this logic, let's just kind of go over this and see whether it will work or not. So the first iteration going through this, global blink counter was initialized to 0, so it does not equal to 20. So it's going to skip the rest, right? It's going to increment. Then blink counter becomes 1. The next time it comes in here, 1 does not equal to 20. Skip this block, increment to 2. So it's going to do this like 20 times. After 20 times, it does increment to 20 after the last one. Then we get back into this code again. Then it equals to 20, right? So at that time, it's going to invert the state of the enabled property of image sprite 1, which basically turns it invisible. I'm not sure whether enable or disable turns it invisible or not, but it would disable it. And I think it would at least, well, we'll see. And then it will reset the blink counter back to 0, so we count from 0 again.
Make the whole thing rotate all the way around before it blinks out?
No, it's 20 times, so it's kind of like an odd angle when it blinks out. If you want it to be like do a whole circle before it blinks out, then you can just compare to the heading.
Yeah, but it's under, that's what I mean, like, are we incrementing heading by 5?
Yes, we're incrementing heading by 5 each time, so it will take
20 times, right?
no for one full revolution. It will take
No, I mean the counter is going to go up 20 times before it blinks out.
Yeah.
And then that would have gone up the heading.
the heading will still continue to rotate. Yes, so we can put a condition to guard it from rotating, but I just want to see whether it blinks or not. Okay. And then we have to look at the designer and look at image sprite 1 and see if there are any other properties that might suggest whether it's visible or not. Oh, okay, maybe we should just toggle visible then. So I got it wrong, sorry. So we'll toggle visibility instead of enable. So that's easy to fix. We just change to the visible property here. So even when it's not visible, it will keep rotating. So when it reappears, it's not going to be the same angle as when it blinks out. Okay, now that can be fixed. Okay, we'll fix that later. We'll check one thing at a time. We just want to check the visibility part now. Okay, there we go. Okay, get it reinstalled. All right, get back in. Canvas 1. So it's approximately 2 seconds. 1, 2, 1, 2. Yeah, so it's approximately 2 seconds. Is that good? Kind of what you're looking for?
Yeah, I was going to do it where it shows the wording panic attack.
Oh,
So
okay.
then when a person has a panic attack, they'll hit it and then it will go to another soothing screen.
Oh, you can do that. Well, if you want to do some cute animations, you can actually make multiple versions of this icon, with like friendly face, angry face, happy face like that. And then, with transitions. So you basically it's the old style of animation, right? You keep a stack of those images and then you just change the image, per click or, or something like that. So you
How do
can,
you do that?
what?
You do all that, what you just said, where you have all these different
Well,
faces.
it's going to take a lot of time to create the artwork first, right?
Oh, you have to create the artwork.
Yeah, so you have to go back to the original artwork, which I might still have open. No, I don't. So to do that, to do that kind of animation thing, which is a really crude way of doing animation, but nonetheless, it still has the right. It will still look kind of cool. So you have to go back to Inkscape, get back to the original image, and then you have to kind of curl this line here just slightly, right? Because you don't want to make it go angry like you want to click. So you want to have the final state, which is really angry, and then you want to fill in with like 5 steps in between, so that the face gradually turns angry, right? So with this face, there are a few things you can use to cue as a cue of the mood of this kind of figure. The background color is one. Okay, so blue is kind of like a tranquility kind of color, right? So you can gradually change the color of the background to red, right? From blue, okay, and then you can make the face kind of frown like this, and do it also kind of gradually. Now with Inkscape, it gives you lots of tools to do this sort of thing. I probably have to undo it, after all this stuff here. So if you click on something like this, you can see that it's controlled by 2 dots, but you can insert additional control points. And I haven't used it for a while, so I cannot quite remember how to insert control points. I think it's this one here. So there you go. So once I insert a control point, then you can make it, you can just raise, no, this is moving it. Okay, undo. Let's see here. Okay, drag to shape the path. Okay, nope, that's not what it does. Okay, something is not right. It's supposed to let me more shift.
Upper right on the top of the toolbar.
Yeah, there you go. So you can make it raise its eyebrow. Yeah, go ahead.
I was saying that button all the way up in the upper right of the toolbar.
Upper right here.
That one. What does that do? Oh, shit, not that one.
Yeah, But you can basically make a frowny face, and I mean you have to kind of experiment with this a lot, to kind of figure out what you can do with it. I think this will do something. Let me try this. Move along axes. Nope. Drag out a handle. Click to toggle selection. Drag out a handle. So you can do it like this. And let's see. If you want it to be frowny, you actually want to move the control point itself. Drag to shape. It's not supposed to move the entire thing. I just want to move the control point itself. So we try shift already. Control is move along axes. Alt is to sculpt nodes. Okay. Alt. Nope, doesn't. I think it overlaps with a window control, button. So, but you can play with that, okay? And you can have you can reshape, these features just very slowly. Every time you reshape a little bit, you save another image, but then you have to save the images like animation 1, animation 2, animation 3, and then you go through your code to refer to those different images. Takes a little bit of work, both in terms of the artwork and also the blocks, because you have to combine a counter with the base name of an image to form the actual new name of the image file, and then have the sprite to refer to the new image, as you go through the animation slices. But it can be done. I mean, it can be pretty cool. So I can play with this a little bit more when we get to the lab, but right now we'll just say that yes, we can do that. I mean, that's certainly doable. So are we good so far with all this? Okay. So what we'll do today is to continue to take a look at what a sprite can do. So sprites are actually the center of attention when it comes to using the canvas. Look at this one. Collided with. Handler for collided with events. Called when two sprites collide. Note that checking for collision with a rotated image sprite currently checks against the sprite's unrotated position. Therefore, collisions checking will be inaccurate for tall, narrow, or short, wide sprites that are rotated. So that means if you want to write a game and you say, okay, when this ball collides with this thing over here, I want to know about it because I need it to bounce off, or I need to decrease a point or increase a point or something like that. This can help you. So you can program a sprite to go in a certain direction, using the heading at a certain speed, using the speed and also the update interval, and just forget about it. Okay, it would just do it on its own, moving along until it hits something. So the collision detection allows you to do that. You basically just say that, okay, I don't need to keep track of my sprite. It would just do its own thing. So are we good so far with this? Now, the other parameter here tells you which sprite is colliding with, which is really helpful, okay? Because you can now say, oh, we need to do something with the other sprite, like make it blank, make it disappear, okay? So that's really cool for certain simple games. The second one is dragged, okay? So you can drag a sprite. So on all calls, the starting coordinates are where the screen was first touched, and the current coordinate describes the endpoint of the current line segment. So basically, it is the same thing as what we are doing before using the canvas drag, except this one is specific to a sprite. So when you touch on a sprite and drag it around, then this event will happen. But it will happen repeatedly, because as you drag the thing around, it will create new events. But if you want to write a game, sometimes you want to know whether your sprite has hit the edge, right? Okay, I bounce off the edge, I bounce off the edge here. This is the event to tell you whether your sprite has reached a particular edge. There are 1, 2, 3, 4. There are 8 options, okay? So the 8 options are here. They are indicated by the edge parameter. So this particular event handler will not only tell you that your sprite has hit something, it hit one of the edges, it will tell you which edge it has hit. So it can be the north, northeast, which means it is actually touching 2 edges at the same time, east, southeast, and so on. So you can make a bouncy ball, kind of app, pretty easily. You just animate the ball and go in a certain direction, and whenever it, get to the edge reach event, you just go like, okay, we'll go the opposite direction. Okay, are we good so far with this? Okay. Flung is the same thing as the flung event in the canvas, except this one is also specific to just a sprite. So when you have multiple sprites, then each sprite gets its own flung event, which can be handy, right? You can fling something that to mean one thing, fling the other thing to mean something else, and so on. This is interesting. When 2 sprites collide, okay, when they hit each other, if you don't do a single thing, they will stay overlapped. But when they get out of the collision state, this event happens, no longer colliding with. So it gives you 2 points of inserting your own logic. If you want to write a game, that involves your sprites, running into each other. When they first run into each other, you get 1 event. When they are no longer overlapping, you get another event. So that kind of gives you, an option to, do something, with the logic of your game, using this second event. Are we good so far with that? Okay. Next one is touchdown, which we talked about already. So this is a one-shot thing. It only captures the one position when the finger touches the sprite. Okay. And then touch up is only happening when you let go of the sprite. And then touched is, we talked about this, I misunderstood touched to be like continuous, but it's not. Because, this one basically, so it's basically a tap, okay? They should have called it, tapped instead of touched. So are we good so far with all the events that a sprite can intercept? Yes?
When you talk about touch up, touch down, and touch,
Mm-hmm.
are you talking about the button or
Nope, the sprite.
what's the sprite?
The sprite is what we just used. So when we go back to here, nope, there are no buttons.
Oh, okay.
All of those things that we saw with this app, those are all sprites.
Oh,
Okay. Okay, let me, oh, you guys can't see it. It's no longer here. Okay. Okay. So this is a sprite. It's a sprite that is rotating. And we are controlling the visibility, so sometimes it's on and sometimes it's off. But it's a sprite. And it can move and collide with other things. Okay? All right, so just for the sake of demonstrating, that the sprite can move on its own and it can collide with the walls and stuff like that, let's just do that, okay? So we'll animate this thing to bounce around, okay? The connected device is unable to access data. Yeah, I think so. That's why this is I think this cable particularly is not a very good cable. All right, so we go back to this logic here, and well, let's see. We'll just make it rotate, or make it go in a certain direction that is not random. 20 degrees, okay, fine. And updating at 100 every 100 milliseconds. Okay, that's cool. And we have to specify a speed, which is the number of pixels that it's going to travel per 100 milliseconds. Okay, so we'll go with something that is 25. We'll give it a try first and see what happens. Now we go back to the blocks, and then we have to specify what happens when it collides with something, right? So we go to image sprite, and then we say when it collides with an edge, or when it reaches an edge. There we go. Then we'll do something. Well, now now it seems like it's going to be difficult, right? Because we have to figure out how to bounce back depending on which wall it has hit. Because if it, yep, it's heading. Heading is where the thing is going. So you can basically look at the mirror image of that. But the mirror image depends on, well, if you hit the north wall, then you want to keep going horizontally, but flip the direction of the vertical. Okay, so it seems like there's some math involved here. Well, anticipating that App Inventor actually gives you some really cool functions to do it, like bounce. Because that's all you need to do. So makes it exactly. So bounce does all the calculations for you. Okay, you just have to tell it which edge you have touched, and it will do all the calculations for you to find out, oh, the new heading is going to be this way. It will keep the speed. Okay, so it will just be constant, right? No, collided with does not, because collided with simply means that you have two things that are overlapping. So maybe you don't want to bounce, right? Most of the time you actually do not want to bounce, but occasionally you do.
I was just thinking pong, so when you hit that paddle,
Uh-huh.
bounce, so.
Yeah, so you will have to figure out that math too. It gets actually more tricky than that, because if your ball is because it's not going to stop when it hits the paddle, because it might have gone over the paddle already. So you have to kind of watch out for those things. Okay, so this one is relatively easy. We're just bouncing it around, and you can see the logic to handle the bouncing is really simple. Okay, so we'll check it, right? Can it really be that simple? It's unable to compile this object, and the compiler error was nothing, and then it gave me a file to download. It's like, okay, let's start the screen again. Oh, I forgot to turn off the blinking. So this might be disorienting a little bit, because it's blinking, rotating, and bouncing around at the same time. Definitely needs to be defragged. Yep. Bing, boom, boom. Uh-oh. There you go, because it blinked out. It blinked out again. You can see the blinking, also, change the phase, because it changes the heading, right? So this is actually kind of interesting, because I keep rotating it and it's moving around. Okay, so let's turn off the blinking, because so that we can actually see the full effect of this thing. And that's fairly easy to do. I just have to take off this block here. Just that one too. The other one, the rest can stay. So we just disable the block.
That bounce is just automatic?
Yeah. That bounce is automatic. Yes. It's just this call here. You give it the edge and it bounces. So it's really...
Close this one like you did on the last
Yeah, sure, I can do that. Yeah. This makes a really interesting interface, to specify, how upset somebody is. So it's like, if you're really upset, just do this. If you're kind of calm, you go like, I'm good, right? So by tracking the motion of how you drag the icon, we can determine whether someone is sad or, happy or. That would make a very interesting interface, I think, for people to enter their current state of mind. Like, we can make an app called, oops, yeah, that work. There we go. So you now see the full effect of the rotating and the bouncing combined.
Can you stop rotating yet? Well, I mean, it's doing something weird.
Yeah, because it's rotating on the path, right?
Yeah, so I want to see what it looks like without.
Oh, okay. Without my own rotation code? Okay, so we can do that. So we just have to turn off the code to do this. So we just disable this block. This is a really cool feature, disabling a block. It's the same thing as commenting out code. So it is still here, it's just that it doesn't do a single thing at this point, so I can test the code program without that block of code. And trust me, to do something like this, using the full Android SDK tool is going to take a lot longer. This is like just a few things. Drag and drop a few blocks, you're done. All right, so let's do it again. There we go. It's a little bit more predictable.
Jumping, right? That's what I was trying.
Well, the jumping has to do with I'm moving 25 pixels every 100 milliseconds.
No, I mean, it's flipping.
Yeah, it is flipping. It has to be, because the heading of the sprite is changed when it bounces.
Is there a way to make it not do that?
I think that checkbox might do that. Yeah, I know. Yeah, so if this is not what you want, you can turn off rotates. If you turn this off, I think that will fix that problem. Okay, well, we'll give it a try. I think this is the reason why they have rotate being able to turn off, is when you move it around, you don't want to actually rotate the image itself. Sometimes. So other times you want to turn it on, and sometimes you don't want to turn it on. Yeah, the Pong game thing can be a little bit complex, because if the ball is going too fast, it may not actually collide with the paddle. So yeah, so that becomes a little bit tricky, because the movement is quantized, so it can basically just tunnel through the paddle using quantum physics terms. Quantum physics is cool. There you go. But you can see how sometimes it actually goes beyond the screen a little bit before it detects that it has touched the edge.
But
Only
it
on
only,
that side, though.
Only on that side, that is correct.
That would annoy the shit out of me.
That it goes off the screen a little bit.
Only on one side. If it did it equally on all sides.
Does it do it at the
Two
bottom?
sides. It does it on the bottom and
In the bottom too.
but not north and not west.
That is interesting. Yeah. Okay.
Fix it.
You can probably fix it by checking with your own logic how close it is to the edge. All right. So are we good so far with this? And all this time, I can the code still works. I can still pick up the black dot and move it around. So you can kind of make this a game. Like, how do you avoid the bouncing ball by navigating the black dot around? And when they collide, you just go like, oh, okay, you just got eaten by the big face. So you have a tiny little gap to move between them. I mean, that's actually really easy. I'll show you how easy it is. Okay, so let's say we want to turn this into that game, okay, where you drag that black dot. If the big,
Different sizes, and every time you beat a level, it goes up a size.
yep, you can certainly do it that way. Yep, so you go to the blocks, and then you just specify, when it collides with something, then we do something, right? So you can go to either one, okay? Because the collision, I think, will trigger both to say that I have just collided with somebody else. So I'm going to use image sprite 1, which is the big face. And if it does collide with another sprite, we'll just turn the entire screen red. Okay? So now we just go to canvas and set its background color to red. So there's red. Set background pixel color. Well, that can be useful too, because that help us remember where the collision is. Okay, that's one way to do it. Okay, why don't we do that? Okay. And it doesn't report back, the location of the collision, but that's okay, because I always know the current location of this image sprite. Okay, but it's not really quite the same as the point of collision. So it doesn't report back, the actual coordinate of the collision. It just says, okay, these two things are colliding. So that's okay. We'll just go ahead and pick up the X and Y axes of image sprite 1 and see what happens. It's going to report back the upper left corner of image sprite 1. So you just go to the XY coordinate of image sprite 1. Okay, here's X. And we'll pick up Y. Here's Y. And the color is going to be just red. Okay, so it stands out because we don't have anything else that is red. So here we go. Build the project again. Okay, there we go. So I can try to move this thing around. Oh. Yeah, I'm also looking to see if I can see the red pixel. And I can't see it. But you guys can take a look too. Yeah, I don't see the red pixel, not on the actual screen either. So something doesn't work. I think the call itself is not working. Okay, I can move this thing around. And I still don't see any red pixels. Okay, let's check out the code here.
You shouldn't set background, but you should set the screen background color to red when they fall.
Instead of setting a single pixel?
Yeah.
Well, it'll be more visible.
And easier to see.
That's true. Okay, so background image, background color. There we go. Okay. Okay. But then it will only turn red once because it doesn't have the code to turn it the other way. We can also use collided with and not colliding anymore. So one will turn it red, the other one turns it back into white. All right, it's almost there. Yeah, the whole source code of App Inventor is open sourced. So if I wanted to, I can actually download this code and run it on the Power server instead of on the MIT server. Did I save the file? So it's still waiting, right? We'll just do it one more time. Oh, that's the other question. How do we specify the icon of your app, the APK? So we'll talk about that next. But we'll make sure the screen does turn red because the collision detection should work. But I cannot see the red dot, which is kind of strange. Yeah, it is kind of slow. Well, it depends on the virtual server that they are using. It might be on a platform where it's shared with many other applications. All right, so let's upload it. Oh, okay. That just gives me the display. This uploads it. There we go. All right. And where's the black dot? There we go. It's somewhere that it is not visible, but the screen did turn red. All right, cool.
Why it's coming off the image Sprite is coming off screen is because
Yeah.
the canvas is a little bit too big for us.
Oh, right. The canvas is actually wider than the screen itself. That is odd because in the designer I made it as wide as the parent,
I encountered that a couple times.
so it doesn't actually work correctly. Okay.
100%. Would that work?
Well, few parents.
That should work.
Yeah, I didn't like Phil Parent either.
I usually use percentage. I do
Okay.
whatever percentage for the size and the rest.
All right. So that should fix that problem. Oh, let's deal with the problem of the icon of your app. Okay. So how do you specify the icon of your app?
The icon of the app. So instead of
The default.
Oh.
Yeah. So I think it is in the screen one as a property. So you can see the app name is canvas one, and then it has screen orientation, size, classic, title, version. Nope. Can't remember how to specify that. There's got to be a way to do it. Background color. Okay, let me just right here. I forgot. So you can use a sprite, use the same image if you want to, as the icon of the APK. So this is how you can do some branding, instead of having the super generic, MIT App Inventor, icon, you can now have your own icon. Okay? And then we're going to go to the blocks, and change the collision thing again. So when it collides with, it changes to the red color. But when it stops colliding, when it's exiting the collision, then we'll change it back to the white color background. So we go to no longer colliding with. Come on, right there. And So it can tell you whether it is colliding or not just by using the background color. That's the idea. And then save, build. The cool thing is you cannot forget to save the file, because whatever you're doing is actually being done on a remote server. So by the time you see that the block is here, it means it's already saved. App Inventor used to be a Google project, and then at some point Google just decided to give up on this project, and then MIT picked it up from Google. So there was a long time ago, in version 1, that Google was actually the host of the project. Cool. Almost there. All right. So go back here. Install first. And then I have to restart the screen again. Nope, no, it should still be around. There we go. Okay. Yep, much better. So that explains why it was kind of doing that. So now I can try to navigate this ball here so it avoids the collision like that, and whee. Being. It actually takes care of the transparency as well. So wherever your sprite is transparent, it is not considered colliding. So it takes the alpha channel into consideration, which is kind of cool.
It does turn it red without actually touching.
Oh, you mean, so it's a square?
Kind of, I think so. Not all the time, but if you pay attention. That time it didn't do it. Maybe it's,
no, I think it's only using the non-transparent part of your image.
See?
Just a little bit? Okay.
Not that much. Sometimes, but not all the time.
Okay.
It's probably the upper left corner jazz, too.
See that last few times?
That's fine.
Yeah.
But now you see it crosses right in the middle, but when it crosses, you'll see if you watch, probably on this run, it's like every other run.
Yeah.
See, it turns red before it touches. Run away!
You can remake the classic
It's wiping your line too.
Yep, it is.
That was interesting. I didn't notice that at first. Yeah.
Yep. But you can see how you can write very simple games really quickly. And also, by the way, you can always check the background color of your pixel. So that means if you want to make a racing game, you can actually have the pixel to check the background color to see whether it's still on asphalt or it has slid off to the side or it's in a canyon.
I think you should cut out a wedge from your image, and then when it collides, you use the whole image. And when it doesn't, it has like a mouth. Run away.
You can remake the classic Pac-Man game. Yes. Yep, but that's the sort of thing you can do. It's not very complex, it's not very sophisticated, but at the same time, it's quick and easy to code. Okay, you can draw something in the background. Okay, the line went away. Okay, let me just check that. So when we set the background color, that the line went away, because the line was only drawn on the canvas. So when you refill the entire canvas with a new color, those lines have to go away.
Okay.
Yeah, so that's the reason why the lines went away. It makes sense. All right. Before we all kind of go dizzy, we're gonna switch back to this screen here. So are there any questions about sprites, canvas, and what you can use it for? Now, this is not the only way to use a canvas, because there are many other things you can do with a canvas that might, you might find those useful, because the original user interface can only do so much. So we'll just kind of go through this, a little bit. Draw a circle, there's not much to say about it, right? Because, all it does is to draw a circle. But you can also control whether the circle is filled or not. The paint color is specified by the canvas paint property. So you specify the paint property, and then whatever you draw is going to be in that color. And then the next one is draw line, kind of the same deal. You specify the paint color of the canvas, and then whatever line you draw is once again in that color. Draw point, same deal. Draw text at angle is really kind of interesting, because all it does is to write some text at the specified coordinate at the specified angle using the values of font size and text alignment properties. So this means, you can, in a certain way, make your own display screen, especially when you have a lot of stuff to display, alongside with graphical stuff and whatnot. Okay, so it can be quite useful. Okay, the XY coordinate, once again, specifies the upper left corner of the text. Now, the one downside I really do not like about this one is it doesn't give you the box. It doesn't return back and tell you how big that text is, how much room it's taking. So if I had that information, it would be super useful, because I know, how to place other objects around the text. Do you see what I mean? No?
Can we go back to that canvas?
Which one?
The last one that you just showed.
The canvas.
The last game you just showed.
You mean the code?
The picture first.
The picture.
The one that had the.
You mean this part?
Yeah. So when it goes back and forth,
Mm-hmm.
what makes it where you get out of that?
Get out of
This screen.
it.
Okay, that's why. Never mind.
Okay.
So we would have to have another screen. Okay.
Okay. So getting back to canvas, you can get the background pixel color, and the background of a canvas can be an image. So you can actually, if you want to, you can take you can take a drone, okay, take a picture, of a road, okay, and use that as the background, of your car racing app, okay, and you just say, if the color is asphalt, you're still on track. If the background color is not, asphalt color, then the car has gone out of the track, and just simulate a collision, and say, okay, now you have to pay a price to fix the car before you continue, right?
And you get in your pimp outfit, drive down the street.
Well, that car was not street legal to begin with.
Original Grand Theft Auto. We can make that above view. That game is cool.
Now, there's also get pixel color. So get pixel color is different from the background pixel color, because the background is not. So what we did, to paint the entire canvas red, that will show up as the pixel color, but it won't show as background pixel color. So this includes the background and any drawn points, whereas this is only drawn points. Okay. You can save the canvas, which is really cool, because you can make your own tiny little paint program. Okay, you pick a pen, specify the thickness. You can draw circles, rectangles, lines, and stuff like that. When you're happy with the image, save it. So I can see how someone might be able to use this to, instead of typing words to describe somebody's feeling, which is really hard when people are very upset or very depressed. Okay, to type the words, you just draw a very angry face, and then save the image. It's like, this is how I feel at this moment. So that could be kind of cool. It doesn't have to be complicated. Okay. You can save as a particular file name. So when you save using this particular method, it returns the name of the file. Saves, okay, this saves a picture of this canvas to the device's external storage. So what it does is it returns something. How do we know it returns something? It's because of this notch here. So what it does is it will save it using a particular system provided file name, and it will tell you what file name it is saved under. The second one allows you to specify the actual file name, but it also still returns the file name. Okay, so let me show you where we can find more information about this.
Canvases on top of each other?
No, you cannot, because you cannot. No, you can have multiple canvases, but they cannot overlap.
They can't overlap.
They cannot overlap. Now, my question is, if you have two canvases, can you multi-touch? Like, one hand to control one canvas and the other hand to control the other canvas.
You know the answer to that. The answer is probably yes.
I will know the answer in 5 minutes. Let's try that, okay? So because I'm curious too, can you do it? Okay, so we'll say dual canvas. Okay. And we'll just do top down, okay? Two canvases, one top, one down. And let's see. So we go to animation and drawing. Put one canvas here. Specify the height to be 50% of the parent. And the height, the width to be 100%. And then put one ball sprite into it. And then move down here, put another canvas here. There's no problem having multiple canvases. The question is, the one thing is they cannot overlap for sure. The second thing is, can they both be sensitive to touch events at the same time? If they can, it's really cool, because that's how you can write, games where you can have, several places where the user can interact with. And then we'll put a different ball here and change the color. So a black ball and a green ball. There we go. Okay. So now we switch to the blocks, the code side. Not much to do except just to let people drag the ball around a little bit. Okay, so we go here and we just intercept the drag event, and then the same thing here. Just handle the drag event here, and then all we want to do is to update the sprite to the new location. Okay, so we go to ball, and then we specify move to, and all it does is to move to the current X and the current Y location. Because if you don't specify this block, the sprite actually does not move. So you actually have to tell it to move along when we have a drag event. So we can just duplicate this block, then change ball 1 to ball 2. There we go. Okay. Very simple app, but it should give us some information about whether we can touch on both at the same time, which is something that I really wanted to find out anyway. Because it doesn't tell you, the documentation does not actually tell you whether it can intercept multi-touch.
Well, it can't on one canvas, is what you said.
Like, that one I know for sure, yeah. That one I actually know for sure. But when you have two canvases, can it do it? That's the question. Okay. Oh, not this one. We need this tab here. Oh, the other day, okay, my mic just went out. This is why we have rechargeable batteries. These are actually my own rechargeable batteries because the lab people decided that this is not a good idea. So they wanted to keep using alkaline batteries. And they go like, well, it's not really so much for environmental, the factor of being more environmental. It's just convenience. Because if you use alkaline batteries, if they run out, then what are you going to do? But if I use rechargeable and I have two sets of batteries, one in here, one being charged, then I'm always ready. I'll just be using like 20 seconds to change the battery, and I'm back online. So let's go switch to the app here, and then let's find out whether we can drag and move two balls at the same time. We'll do it one at a time first, and then we'll do both. Try to do both at the same time. Oh, right, sorry. Oh, it dropped out. That's why. Okay. Yep, it just dropped out. There we go. You can also see the icon. Is it really because of the connection? Could be. But you can see how the icon is now changed with that first one.
Yeah.
So it's kind of cool. And now we can test a dual canvas. So we'll check each one out, individually. Now we'll go ahead and try to do both. Nope, doesn't quite. Oh, okay, it does work. So you can do both at the same time. Yay! Ha ha ha. That is.
2 fingers?
Yeah, I am.
And you just happened to, you were being very coordinated. Like, it looked not natural.
Oh, really?
Yeah. Which,
Yeah.
if you think about it, I'm wondering.
Years of piano practice.
It looked like they were both tied to each other. That's why I was. You know what I mean? You moved one away, it was weird.
Yeah, but this is really cool because this means that you can divide a screen into like two halves, or however how many quadrants, whatever number of quadrants you want, okay, and put control things into those, like a D-pad on one and then buttons on the other one. So now you can actually simulate the control of a Game Boy. Then you can reprogram all those classic Game Boy games in your app. We'll make it black and white too.
First Grand Theft Auto, the one with no hookers in it. The first one, the original one. From
Yep. Oh, you mean the one that is like just overview and just crashing stuff?
And it was just literally stealing cars and driving around.
Yeah.
It wasn't like, go to the gym and whatever. I don't know. I don't play anymore, but.
Yeah, but this is cool. Okay, so we now know that you can actually have dual touch. Because at least dual. Okay, I don't know. What is the limit on touch screens? Like how many fingers can they track? Because they're capacitive. Yep, go ahead.
I'm just thinking. Wait, all these things, like all these touch features.
Mm-hmm.
Do they have to live in a canvas? They have to live in a canvas, huh? If you want to use.
Yes, they have to live in a canvas. Now, not entirely. Because if one thing is really just a button, you can just use a regular button. And I think you might be able to the look of a button to something else. But if you need to drag them around or track the finger position all the time, then you need to use a canvas for that.
Is there anything that you can't put in a canvas?
You cannot.
Just put a canvas on every screen in case shit.
Well, then you cannot use a list box and other things like that.
So that's what. Okay, so it has
So
those limitations.
a canvas can only contain sprites and things that you draw.
Oh, okay, that's a big problem.
Well, it's
You put a thin canvas at the bottom so you can have like fancy features.
Okay, so before I forget, I am going to export the dual canvas and also the other one that we worked on. So which is canvas 1. So export like that. And then go to here. And I'm just going to send you through the announcements. Okay, just a quick, easy way to send you guys the code. Okay, so this is canvas 1 AIA file. Do you guys know what to do with the AIA file? Just import it into your project, and that's all you need to do. So let's see. This is canvas1.aia. Canvas1.aia, because APK has the same first letter as the extension, so it got a little confused. And it only allows me to do one attachment at a time, and a single space does not count as non-empty text. How about enter key? There we go. Okay, so we'll make another announcement for the dual canvas. Enter. And then we go to choose file and dual canvas. Save. There we go. So now you guys have access to both of these canvas programs. The second one is really simple. I mean, you guys can easily replicate it. But the first one, you got some animation effect, you got some bouncing around effect, you got some collision detection effect and stuff like that. And all this time, I haven't even started to play with the sound part of this. So you can actually start to play a sound when they're colliding, like an explosion sound or something like that. Yep. So you can do a lot of fun stuff, with this. You can also
It's that Black Mirror show, the Choose Your Own Adventure.
I haven't watched that yet.
I started it.
I intended to watch Black Mirror, but haven't
Black
really.
Mirror is awesome in general, but that specifically is that. What's been out for a while?
Is it Amazon?
Choose Your Own Adventure? No, on Netflix. Where,
Oh, Netflix. Okay.
You go like, have him eat the cereal, have him play the, you can choose.
Mm-hmm.
You die, basically, like the old books.
Uh-huh.
Start you back to the beginning of the show. It's interesting how they did it. And it's edited like it's smooth, like you wouldn't know. So you choose this path through the movie.
Mm-hmm.
And it's part of Black Mirror, and they're gonna do a bunch of them now.
Okay.
But you can make a video game of like Choose Your Own Adventure. Like, I just wish I was creative enough to do it.
I have to finish the Voltron series first. I gotta prioritize, man. Voltron comes first.
What's that one about? What?
It's an animated series remade. DreamWorks remade it basically. So
179, what the?
yeah. Oh, you mean this one?
Oh my.
Any of them? That's way freaking expensive.
It's Legos. And this is that the new Voltron or the old Voltron?
That's the old one.
That's the old one. Well, the new one.
I don't know. I don't know what the new one looks like. That looks familiar to me though.
This is the new one. This is the new one. They still have the same colors, but it's the same character design as what's the name of that show? Avatar.
Okay.
The last Airbender. Yeah. So it's the same character design, so you can actually see.
Avatar.
Hate that movie. Okay. No, not that movie. It's the animated series, the Avatar. So it has a lot more character development and less of the actual robotic, fighting scenes. So it's different. It feels completely different from the old Voltron that I used to watch. I mean, it still has that kind of element, like Voltron forms and blah blah blah. It still has that particular element, but it has a lot more intricacy in terms of character development, the backdrop, the whole thing, the politics.
So it's like a series, not like episodic or whatever they say.
It is still episodic. But it's leaning more on the Gundam side than the typical, Japanese one episode, type of thing. So the storyline is very continuous, and there are multiple threads, that are developing at the same time.
Trying to watch old shows, I don't know, like lately, that's amazing. How much you care about new storyline. Like, I can't even do it anymore. I'm like, dude, what's the point of this episode from the last episode?
Yeah, I know.